Hello, we are Team 18, and our final project topic is fake news classification using hybrid CNN and RNN model. And the main premise behind our project is that it is seen in the recent past that there is a rampant surge in the spread of fake news. And to circumvent the spread of fake news, we undertook this project. So, through this project, we would like to curb the spread of fake news by building models that would differentiate between authentic news and fake news. So we have used three types of data sets. The first being the fakes data set, and the fakes data set is about the Syrian war, and the news articles are revolved around the Syrian war, and it has about 804 news articles. And on the right, we can see that there is a snippet, a small snippet from the data set, and um, uh, yeah, and the next data set that we have used is the liar data set, and this is also a publicly available data set. And this data set has about uh, 10 years worth news articles, and there's a small snippet of the liar data set on the right. And the next data set that we have used is the ISOR data set, and this is mainly a political news data set, and it is also split into fake news and real news. And there's a small snippet of the data set on the right, and as we can see, the segregations of the types of newses.
Yeah, so this is the baseline model that we built using a mixture of CNN and bidirectional STM layers, and we trained the model on all the three data sets, and everything was implemented using Keras TensorFlow library. So I'll just go to the layers of the model. So we used Glove embeddings for our word embeddings. So Glove is a standard library from NLP word embedding library from Google. So I'll just explain the layers now. So the first layer was the convolution 1D layer with kernel size 5 and 128 filters, and the activation function used was relu. Then it was passed through a max pooling layer of window size 2, after which it was passed through a bidirectional STM layer having 32 units. Finally, it was passed through an output dense layer with sigmoid activation, and the final prediction was outputted. So the results on ISORT using the baseline model were pretty good. So the F1 score was around 0.96, and the accuracy was also around 0.96. And the confusion matrix can also be seen on the screen. Next, we trained the model on the fakes data set. So the results on fake data set were as follows. The F1 score was around 0.5, and the accuracy was also around 0.5. Then we trained the model on the liar data. So the result that we got on the live data set were as follows. The accuracy of the model on the training data was 92, and on the testing data, it was around 74.8. The F1 score was around 0.85.
Moving on to the BERT model that we've used to create word embeddings. BERT is one of the most famous word embedding techniques that is currently being used in the field of NLP. Going on to the results on the different data sets. For the liar data set, we see that the fake news was detected very well, and as shown in the accuracy, which is 0.82, it is much better than the baseline model. Go on to the next one. Coming on to the fakes data set, this did not perform much better when compared to the baseline model. This may be due to the small BERT only uses the first 128 tokens to classify the data into fake and real. So it might not have enough information to properly classify the data, and hence why it might not have been performing that well. Going on to the ISOR dataset, the BERT model performs exceedingly well on this dataset, and it is able to classify almost all the documents into correctly into real and fake news.
So the next word embedding technique that we tried was ELMO. It is known as embeddings from language model. So ELMO, like BERT, does retain the context for forming the word embeddings. So it is a state-of-the-art NLP framework that was developed by Allen NLP. And apart from context, it also trains the word embeddings using syntax and the semantics. So we used the ELMO embedding technique with our baseline model and tried to get an improvement on our results, like similar to BERT. So the results on the ISOT dataset were almost similar to the baseline model. We got a FN score of around 0.96, and the accuracy on the testing data was around 96.54%. So the result on fakes dataset was as follows. We saw a huge improvement on the accuracy of testing data, which increased to around 65%. The FN score was around 0.88, and the accuracy was around again was around 0.65 for the test set. So